So very good evening. So happy Diwali. Wait for just one more minute and then we'll pitch in. Yes, it's all sound of crackers everywhere. So, so we have been dealing with class 12th CBSE Computer Science. And as per the NCRT syllabus, we had the introductory topics of the language Python covered. And we started with data structures. So as per the syllabus, you had to learn stack as well as queue. And we are into the stack. So we have been learning the definition followed by the different operations and then the major classifications or categorization in data structures. And then we were looking into stack in detail. And today we are in the last part of stack applications. So with today's class, we'll be winding up our study on stack and then we'll resuming with the study of the next data structure, that is queues. And then with that, we'll be completing the chapter 9 and then we'll have a discussion on questions. So this is a routine that we always follow after covering each of the chapters. Okay, so I think it's time and let's pitch in. So, a very good evening. Happy Diwali to all my students. So, welcome to Let's Crack CBSE Science and welcome to my class. So, before moving on to the class, let me give you a brief introduction about myself. Hello, all. I'm Shalini. I am a BTech and MTech holder in computer science and engineering. I'm a teacher by profession with over 14 years of teaching experience. And with Unacademy, I'm excited to provide an inspiring learning experience to all the students via this online platform. So, now before moving on to the class, let me give you a brief tour over Unacademy and its various subscription details. As you all know, Unacademy has grown to be India's largest e-learning platform, not because of the reason of the pandemic situation, but also for the reason that it has grown out to be a one-stop destination for a CBSE school-going student to an aspirant who is preparing for the competitive examination. Okay, you get all courses underneath one shell, and that is Unacademy, and thus it has grown out to be India's largest e-learning platform. Now, what you get in Unacademy, you get access to the daily live classes, and all the courses here are well structured and in line with the current examination syllabus and from the best educators all over India. Now, there are live tests and quizzes which would help you to evaluate your preparation as well as gives you an analysis of how well you are preparing or performing towards the forthcoming examinations. And once you get a subscription to Unacademy, you get unlimited access to all the resources of Unacademy. Now, the resources are mainly the treasure, that is the classes. The classes come in either live form or in the recorded form, which can be viewed at the comfort of your time, device. Okay. Now, if you miss out a daily live session, you needn't worry because once you have a subscription, you get access to the recorded classes also. So in the daily live class, it is not just a mere attending or a monologue session. Here there is a facility to chat with the educator, engage in discussions, ask your doubts and answer via polls. Now all the facilities while the live class is going on. Now, as I told you, the courses are well structured in the meaning they are in line with the current examination syllabus. So, this would help you to prepare better for the forthcoming examination. And also, the test and quizzes would help you to gives you an analysis on your performance. Now, this is how the comprehensive syllabus would look like. Since we're dealing with CBSE class 12th, now this is how the syllabus would be looking like for a school going student. You would be having the different subjects, and underneath each of the subject you'll be having the courses listed. So you may please click the course and then offered by the various educators. So based on your need and priority, you may click on the courses and listen to the classes. Okay. So this is the Unacademy Learning app, which you need to download from the Play Store and install in your smartphones, and then get the subscription based on your choice and based on the time plan that you would like to take a subscription of the Unacademy. Now, apart from that, there is a Telegram channel. All you have to do is download the Telegram app and see the link. Now, this link has to be pasted in the URL, and then you need to click to join to the Telegram channel, wherein you get access to the study materials as well as the timings posted by the various educators. Now here we have the CBSE class 12th subscription fee details. Now this is the most important thing. So if you wish to take a subscription, then I would say this is the table which gives you an idea about the plan, and across each of the plan the cost of the plan also. So the subscription plans ranges from 1 month subscription to a year subscription, wherein the plan charges are from 2,500 to 12,500. But here is an attractive offer. If you apply my referral code or my promo code SLYT, if you use this promo code, you get a discount of 10% on the fee. That is, the fee gets reduced to 10%. If you are taking a month subscription which costed you around 2,500, after applying the code would cost you only 2,250. Now similarly, the same 10% reduction is applicable in all the plans given below. And if you are a class 11th or a 12th student, then I would definitely recommend you to take your subscription, that is a subscription of 12 months. Now, this would not only help you for the forthcoming board examination, but also for the examination if you're preparing for the joint entrance examination. So, you would have classes with respect to that too. Okay. So, that's all about Unacademy. And now we're going to pitch in to the agenda of the day. Now, as I told you, we have been dealing with CBSE Class 12 Computer Science. Okay. And we have been learning stacks for the last couple of days. And today it is the last session. So, today's session would be a very short session wherein we would have a small recap, or it is almost the same as what we discussed in the last class. Plus, we have additional of little problems wherein these stack applications can be performed. Okay. So as usual, these would be just the contents. There is nothing pretty much, but we'll be looking into a few of the problems and how to evaluate or solve those problems. Okay, so stack, the definition says it is a linear structure implemented in LIFO manner. Okay, so we had already seen that the data structures are classified into simple and complex data structures, wherein the complex data structure were again classified into linear and non-linear. Now the stacks comes under the linear structure. Now this follows a LIFO technique, that meaning last in first out manner. And here the insertions and deletions are restricted to only one end, and this end is called as the top of the stack. And not only that, apart from this, we also saw that the operations where there was specific terms associated with the operations. Now what were the operations? Insertion and deletion, right? Now the name associated with insertion was push operation, and the name associated with deletion was pop operation, and the restriction was whether it be a push operation or a pop operation, everything happened only through one end, and this end was called as the top of the stack. Okay, so this is a recap of what we saw in the previous class. And we also saw that we listed the main 5 stack applications wherein we learned reversing a line of text. Okay, that means a string. A string could be easily reversed using a stack. Now, what was exploited? What property of the stack was exploited here? We exploited the LIFO technique, that is last in first out technique of the stack. So whenever you are reading a string from left to right, each of the character in the string was pushed onto the stack. So what happened? Now I told you that the pushing operation can happen only through one end, and the first character to be pushed would be at the bottom of the stack. The second character would appear on top of it. So this would be like a second last position, and likewise the top of the stack would be pointing to the very last character of your string. Now when you try to pop out, what happens? All the characters appears in the reverse order, and hence reversing a line of text. Okay. Then we learned the conversion of infix to postfix expression, wherein we learned an algorithm which told how to interpret the precedence and how to interpret the associativity with respect to infix expression, and how this particular expression was converted into the postfix equivalent. Okay, and then we also learned how to evaluate a postfix expression. Okay, so we are given with a postfix expression and values for the operands, wherein we evaluated to find the value of the expression. Then we learned that in the process of recursion, now what was that? Recursion was something that was with respect to a function. Now this was a technique in function in which the function could call itself, right? So whenever there is a function call, the control gets transferred from one point to another point. Now which was this another point? One point meaning from the point of function call to the point of function definition, right? Now after the function definition was executed, it has to come back to the point of call, right? Now to traverse back, what should be done? You need to have the return address saved, and hence in the process of recursion, what do we use? We use stack. Now similarly, we also learned that in the process of backtracking, what was it? Backtracking. Backtracking meaning you're tracing back the route that you have gone, but in the reverse order. If you have to travel back in the reverse order, you need to have saved all the nodes or all the paths on the way ahead, right? So in this technique also backtracking was, in the technique of backtracking also stack was applied, because when you have to travel in the reverse order, the point that was visited very last should be the point that should be taken first, right? When you're traveling in the reverse order, and hence we saw that for all these applications stack could be used. Now we'll be looking into a few problems. Now prior to moving into the problem, Now, this is just to refresh your memory. That is, when you're trying to evaluate an infix expression or when you're trying to convert it into the postfix notation, we need to keep in mind something called as precedence or the evaluation order, the order in which the operators are executed. Is the idea clear? Now, below is listed the precedence order or the evaluation order. The first priority should be given to brackets or parentheses. Okay. Second priority for the exponentiation operation. The third priority for multiplication as well as division. And the fourth priority for addition as well as subtraction. So this was the priority order or the evaluation order. So your infix expression would comprise of parentheses and all the other operators that is shown here. And this is the order of evaluation. Now this is what we call as precedence or evaluation order. Apart from the precedence, what you need to learn is the operators with the same priority. See here, multiplication and division in the same priority. Addition and subtraction again in the same priority. They are evaluated from left to right. So this is what we call by the term associativity. Okay. So these are the two things to be kept in mind. Now, see here, the three types of notations are infix, prefix and postfix. Wherein infix we have the operator fixed between the operands, and in prefix we have the operator fixed that is before the operands, and in postfix we have the operator fixed, post meaning after, right? After the operand. So this is how the example of an infix, prefix and postfix notation be. Now see this expression a plus b asterisk c. Now this is an infix expression. So the priority has to be first given to parenthesis. Now what does the parenthesis say? We first convert it, right? So this would be bc asterisk, right? If you're converting it into the postfix notation. So what would happen now? A is an operand, BC star is next operand. So how would you convert it to postfix? You would write A, B, C star plus. See how you have arrived at the postfix notation. Now the same thing that I'm going to find the prefix notation. I'll show you how this could be done. Okay, so you are given with the expression and then see how this would be written. A plus. Now, how would the expression inside the parenthesis be converted to prefix? You have the operator followed by the operand, right? So, asterisk BC. Now, this is an operand and asterisk BC is your another operand. How would you convert it? You would write plus the operator first followed by A and asterisk BC your next operand. So, this would be your prefix notation. See how you arrived at it? So, I hope you understood how to convert a given expression to a prefix as well as postfix. Now in today's class we'll be looking into a few examples problem wherein we'll be learning how to convert a infix expression to a postfix, how to evaluate a postfix expression, wherein we learn the algorithm in the last class. Okay, so now let us see this. Okay, the last expression. Now we already have parentheses to show that this is the innermost expression and here the outermost expression. In this case again this is the innermost expression and this is the outermost expression. So only after evaluating one in the parenthesis can we check for the other priority. So in this case let us first assume the conversion to postfix. So how would this appear? A plus BC asterisk, right, slash C minus DB asterisk, right? Now this parenthesis has to be resolved. So it will look like A, B, C asterisk plus C, DB asterisk minus, okay? And now two operands and an operator. Now this would look like ABC asterisk plus CDB asterisk minus, and then you would have the slash at the end. See how it got converted to the postfix. And similarly, when you have all the operators listed on before, we would have the prefix notation. So let's see the prefix notation also. So in prefix notation, what is to be done? You need to convert it into the form wherein you have the operator followed by the operands, right? So how do you convert it? You write A plus, okay, asterisk BC, okay, operator followed by the operand. The innermost expression is first converted and then slash. How about the second expression? C minus star dB, right, or asterisk dB. Now why? Because in prefix you first write the operator followed by the operand. Now again you have parenthesis, so this has to be considered first, right? So when you're trying to convert it into the prefix notation, this would come like plus A asterisk BC. Now this is the your first expression divided by, how about this one? This would be like minus C asterisk dB, right? Now this is of the form operand, operator, operand, right? So again, the entire expression has to be converted to the prefix notation. So this is your operator, it has to come first, followed by your first operand, that is the first expression inside the parenthesis. This would be like plus A asterisk BC, right? Followed by minus C asterisk DB. See how you arrived at the prefix notation. So this is how the evaluation or the conversion would be happening. Now today we'll be concentrating on problems with respect to postfix notation, conversion to postfix notation, and then the evaluation of postfix expression. So I have cited a few examples here. Now let's see the first one. First expression A plus B star D. Now every time you would be given with such an expression. Now what is the first step that you have to do? First step is you need to give parenthesis and give the evaluation order. Okay, you have to give parenthesis to the expression, and then this parenthesis would be giving the evaluation order or the order in which the expression has to be evaluated. Now how do you travel the expression? Every time from left to right. Okay, now as you travel from left to right, we see that now here there is no parenthesis given in the expression or in the question, so you are the one who's going to put the parenthesis. Now in this case, which is the operator that is having highest priority when you compare plus and asterisk? Definitely asterisk, right? So this is the one to be given priority. So you would write B asterisk D in parenthesis to show that this has to be given priority. And this is how the entire expression would look like. So if you have to convert to postfix, so you're given with infix, you need to convert it into the postfix. So first the bracket 1 inside the parenthesis has to be converted, right? So how do you convert it? You first write the operand followed by the operator. So this would be looking like BD asterisk. Okay. So is your entire expression converted to postfix? No. So again, you have to, so here at this point of stage, A is one of the operand, which is the other operand, BD star. So how would you convert it to the postfix notation? Now plus should come at the end or at the tail end, right? So you have the first operand followed by the second operand and then the operator. So this is how the first expression would be converted to the postfix notation, and see how you arrived at it. Okay, the one written in red color font is the final answer. Now let us see our next question. Now in the question it is given P slash Q minus R. Now, in the expression itself, you're given with a parenthesis. So, it shows that the one in parenthesis should be considered first, right? So, P bar slash Q minus R. If you had compared slash and minus, actually, which was having the higher priority? Actually, slash, right? When compared to minus sign. But the expression Q minus R is in parenthesis, which is having a higher priority compared to slash. So how would this be done? First, we would convert the one in the parenthesis. Okay. Now, P is an operand. QR minus is another operand. So how do you write it? P QR minus slash. See how you arrive at the postfix equivalent. Lots of noise from the bursting of crackers. So moving on to our third expression. Now what is the operator being shown here? This is the exponentiation operator. So what is the operator? It's the exponentiation operator, right? So I asterisk asterisk 2 means it is equivalent to writing I squared. Okay. Now the exponentiation operator is having the highest priority when you compare the operators. Okay, when you compare multiplication, division, addition, subtraction, whatever it be, the exponentiation operator has the highest priority. So the parenthesis should definitely fall in the expression with the exponentiation operator, right? So how do you give the evaluation order? I asterisk asterisk 2 inside parenthesis followed by the balance of your expression. Now this has to be converted to postfix. You have the operand list after the operand followed by the operator. So this is how it could look like. Now to convert your entire expression to postfix, I would write I2 asterisk asterisk 3 plus. Okay. So this is the final result. So first what you have to decide is, if you're not given with any parenthesis, then you have to start from scanning the expression from left to right. As you travel, you need to consider the evaluation order based on the operator precedence. Based on the operator precedence, you would be introducing parenthesis, and this is the order in which the conversion would be taking place. Okay. So let us see a very few examples. So we have the first infix expression. Now see here, this infix expression itself is having a set of parentheses here. But so we are given with the expression, I write the same expression as such, and then I'm going to introduce the evaluation order. How do I put the evaluation order? I need to travel from left to right of the expression. See here, A asterisk, B plus, C plus D. Now C plus D and E plus F is put in parenthesis. So this has to be given higher priority, innermost parenthesis. Okay. Now, outside these parentheses, you see a plus operator, asterisk and slash, right? So first, what we would do is we would give priority to the, the asterisk operator, because the asterisk and slash has same priority. But when you're traveling from left to right, which is the operator that appears first? Asterisk, right? So first the multiplication has to be done, followed by division. So this is the order. Though they have equal priority, we consider the direction of travel, and which is the operator that we encounter first. We encounter first the multiplication. So we perform that and then followed by division. So how would the conversion happen? First, the innermost bracket has to be converted. Now, prior to conversion, we need to put the evaluation order, right? So this would be C plus D. Outside C plus D, you would introduce a bracket. Asterisk E plus F. Again, this has to be introduced inside a bracket. Okay. And now we see that slash G also has to be considered second. So this would be in another brackets. After that, this is already there in our expression. Okay, so this bracket is already there in our expression, followed by A. Now, because see here, A asterisk followed by the entire expression and then asterisk H. So you're having two multiplication. Now, since you're traveling from left to right, the first multiplication or the first product has to be computed, and then only you have to compute the second one. So, which is the one that has to be given priority when you compare this asterisk and this asterisk? Definitely the one with A, the operand A. Okay. So, this is how it would be appearing. Okay, now we're going to change to the postfix notation. Now let me erase so that this would be a little more clear. So which is our innermost expression, C plus D and E plus F, right? So this would be converted to its postfix equivalent, which is CD plus and EF plus. Okay, now we have to find the product. Now when you're finding the product, CD plus is an operand, EF plus is another operand. So how do you convert it into the postfix? You write CD plus EF plus asterisk, right? Now, which is the next thing to be considered? Slash G. So this is what is to be considered now. Okay. Now, in this case, what we do is, this entire thing becomes your, this would be your one operand and G is your second operand. So in this case, when you convert, you write the first operand followed by G and then the slash symbol. Okay. Now, which is the next expression to be considered? That is one with B. So you have an operand here and this is the second operand. The entire expression becomes an operand now, right? So how do you convert it to the postfix notation? You write the operands together followed by the operator. The operator would be following after the operand. So I would write B and this entire operand. See how I have written here and then the plus symbol. Is the idea clear? Now which is the next evaluation to be done? We have to consider the multiplication. Which multiplication? The very first multiplication. Though we are having two in the same line, since we are traveling from left to right, it is the first asterisk that we need to consider. So what would happen? I would write all the operands, that is A followed by the entire expression I have written here, and then I would put the operator symbol asterisk. Okay. Now what has this turned out to be? This has turned out to be an operand for me. And which is your second operand? H, right? So how do you convert this expression to the postfix? You have the entire expression, then H followed by the asterisk symbol. So this is how the conversion from an infix to postfix notation happens here. Now we'll take one more example and then we'll go with the logical operators. See here, you are given with an expression, infix expression, and this is your expression. Okay. So I've written the expression once more under the subheading given, and then which is the next step, you have to give the evaluation order. Now when I examine the expression, I see that already the expression has some parenthesis. See, B plus C to be given priority, D plus E again to be given priority. Now after computing B plus C and D plus E, which has to be considered first? We need to consider asterisk first and then we would be considering the plus operation, because asterisk has a higher priority when you compare to addition. Okay. Now after after considering the brackets, which do you think has to be considered? After considering this parenthesis, you have A plus, let this be expression slash G. This would be of the form A plus expression slash G, right? When you compare plus and slash, which is having higher priority? Slash, right? So first you would perform this and then after that you will add it with A. So this is how the evaluation order is going to happen. And based on this evaluation order, we would be introducing the brackets. See how I have introduced the brackets. A plus is completely outside because this is going to have the least preference here. Now B plus C and D plus E already put in brackets. Now with D plus E, what has to be, the product has to be given the first priority. So I would show it with parenthesis. After that, I need to add it with B plus C. Okay. So the innermost. Okay. Now the second priority is definitely this. The third priority is definitely adding it with B plus C. And the next priority would be definitely with G. Okay. So this is the order. Is the idea clear? Now, I hope the lines are clear to you, which shows the order. And now let us first convert the innermost brackets to postfix. So what is B plus C in postfix notation? BC plus. D plus E, DE plus. Okay. Now which is the next thing to be considered? We need to consider asterisk F. So this would be DE plus asterisk F. So of the form operand, operand, operator, operand. So when you try to convert it to postfix, this would be like DE plus F star, right? So see here. Now this is one operand here, okay? Another operand is BC plus, right? Now these has to be added up. Now this is an operand, this is another operand and plus in between. How do you convert it into the postfix? So you write all the operands in the first stage and then you would write the plus symbol. Okay. So this is how the postfix notation comes. Look how I have converted it. Now this is one of your operand value followed by G. Okay. Now what is the operator in between? You have the slash operator, right? Just a second. Let me erase this off. So yeah. So this itself, what I have underlined are two operands starting from BC plus 2 ending till plus. This itself is an operand and the next operand is G, right? So when you're converting them to postfix, you would first write the operands. That is the first operand followed by G and then the operator symbol. Now how is this? The entire things become an operand now. So you have A, one of the operand, and this expression as your second operand. Now let me name this as EXP. So this is of the form A plus EXP, right? How to convert it to the postfix? You would write A, EXP plus. So in the place of EXP, you would write the entire expression. Okay. So I hope with these three examples, it is clear how to convert a given infix expression to a postfix notation. Now, certain things that you need to keep in mind is you travel or scan the expression from left to right. Okay. Now, the second thing is the evaluation order or the precedence. If you have to show the evaluation order with the help of parenthesis, you should be knowing the precedence of the operators. Okay. Now, once you're done with the or once you're clear with the precedence, there is no issue. You can easily give the evaluation order. Now, the expression in the innermost parenthesis would be first converted to postfix, and this is how you would be unleashing or clearing of the parenthesis or the priority for the evaluation order. Okay. So with this few examples of infix expressions, I think it would be almost clear to you how to convert it to postfix notations. So here, next we are going to see the priority order of logical operators. we have a very few audience today, I think because of Diwali. So the priority order for logical operators are, the very first priority is given to the unary operator not, followed by the two binary operators and or. Okay, so this is how. So first, every time not is considered, then and, followed by or. So this is the order of evaluation in the case of logical operators. Now let us see this. So you're given with a postfix notation, not A or, not B, not C. Now whenever you're given something like this, you need to understand that the operator and is there in between not B and not C. So I write the entire expression. Now what do? The first thing, I need to find the evaluation order. Now we just now saw that not has to be given the highest priority. So not A, not operator in individual brackets or parenthesis. Now we have or and operators, which is to be given priority, and has to be given priority. So the expression in and is again put in the parenthesis, and or part is treated with least preference when compared to and. Now when you convert not A to the postfix notation, you have to write operand followed by operator, right? Which is your operand here? A, the operator not. So how do you write it? A not. Okay. Similarly, for not B, you would write B not. For C not C, you would write C not. Now, which is the one to be considered now? The one with and, right? So B not and C not. How would this be converted to postfix? You would first write the operand, that is B not C not, followed by the operator and, right? Now, the one in the parenthesis is a operand. A naught is another operand. So operand, operator, operand. Now how would this be converted to prefix? You would first write all the operands followed by the operator. So be it an arithmetic expression or be it a logical expression, the rule for conversion to postfix remains the same. The first thing is traveling from left to right. Second thing is understanding the precedence. After understanding the precedence, you would give the evaluation order. How do you give the evaluation order? By introducing the parenthesis. The innermost parenthesis would be first converted to the postfix equivalent. Okay. And this is how you would be proceeding. Okay. So the next application, we have evaluation of a postfix expression to using stack. So this was a algorithm that we saw in the last class, and the evaluation rule says in a postfix expression there are no parentheses. What are only existing? You have either an operand or an operator. Okay. Here also the traveling happens from left to right. Now when you have an expression, you always scan from left to right. And you encounter either an operand or an operator. Okay. Now what is the action to be taken when you encounter an operand is push. So whatever you get, you push it to the stack. Okay. Now, if it is an operand operator, then you need to decide the category of the operator, whether it is a unary operator or a binary operator. Now, if it is a unary operator, I would pop just one operand from the stack. Okay. If it is a binary operator, I would pop two operands from the stack. Is the idea clear? If it is an operand or operator, what is the action to be taken? The action is nothing but either pushing to the stack or popping or deleting from the stack. Operand, when you encounter, you push it to the stack. When you encounter an operator, you need to distinguish between unary or binary, and based on that, the pop operation is initiated. The process is continued till you reach the end of the postfix notation, and then whatever is in your stack would be considered as the final result. Okay. So we have a postfix expression, say AB plus C star D slash. How to travel? We need to travel from left to right. A, first one. Now A is an operand, it has to be pushed to the stack. Again B is an operand, pushed to the stack. Now where would top be pointing? Now top would be pointing to B. Now after B, I found an operator. Now what is this operator? It is a binary operator. So the values would be popped A plus B. Now what is the value to be substituted? 2 plus 3, wherein you get 5. Okay. Now 5 again is an operand which would be pushed onto the stack. See here 5 is pushed onto the stack. Then when you see your postfix notation, again you encounter an operand and this value would be pushed onto the stack. So your values are 5, on top of which you get C. Now the next one is an operator. So you pop two values. Why? Because asterisk is a binary operator. So C asterisk 5 you get 20. The value is pushed to the stack. After that you have D again pushed to the stack. So on top of 20 you would have D. Then you have the slash operator. So definitely that both the values have to be popped. Now how would I write 20 slash D, right? What is the value of D? 5. So 20 slash 5 would give you 4. See what is the result? The entire result of the expression is 4. So this is how a postfix expression would be evaluated. Okay. So now let us see another postfix expression. Okay. So we are given with now 30, 5, 2. Now the caret symbol shows the exponentiation. Okay. So this has to be denoting the exponentiation. Then you have 12, 6 followed by slash, plus and minus. Now the entire evaluation is shown in a tabular format wherein the serial number or step shows which is the element being scanned from the expression or notation, what is the action to be taken based on the element, and what would be the status of your stack. Any intermediate or final result, whatever it would be in the output section. So this is how I have classified the table. Okay, so what is here? We have over here the output. Okay. Now, the first step, I scan the expression. What is the value that I get? I get 30. Now, what is 30? 30 is an operand, right? So, what is to be done? Push to the stack. Now, for the postfix notation, the first thing that would be pushed would be definitely the opening brackets, right? So, this is how I am writing opening brackets, and then on top of the stack, you have 30. Then I encounter 5. Now again 5 is an operand, right? So this would be pushed onto the stack. So what would be the stack content? At the bottom you would have the parenthesis. On top of it you have the value 30 and on top of it you would have the value 5. Okay. Now again you encounter an operand, a push, and so this would be the status of your stack. Just a second. Okay, so let's resume. Now we have reached till 2, and what is this? I told you this has to be interpreted as the exponentiation, and which is a symbol for exponentiation, asterisk asterisk, right? You can either write it like this or then you can use the caret symbol also. Okay, either way it would do. So asterisk asterisk means exponentiation. Again, it is a binary operator. So how many values to be popped? 2 values, right? So one that is pointed by top is 2. Now once that is popped out, now top would be pointing to 5. So again that is popped out. So how would it appear? 5 raised to 2 or 5 squared. So remember it should be 5 squared and not 2 raised to 5. Okay. So the value that is popped second is the base and the popped first is your exponent. So this is how things have to be interpreted. When you do the division also, how is it? The value that is popped out first is your divisor and the one that is popped second is your dividend. Okay. So 5 raised to 2. What is the answer? 25. Now 25 is an operand. It has to be pushed to the stack. Now this is what is pointed by top. Okay, now you proceed with the postfix notation. You have an operand. Operand means push. Next again 6. It is another operand. What is the action to be taken? Push. So now top is pointing to 6. Right? Now you have the operator. Now which is the operator? Slash, right? So slash is a binary operator. How many values have to be popped from the stack? 2. So I would pop 6 and 12. Now slash. So how is the division to be done? The first value popped would be your divisor. Second one would be your dividend. So it is 12 slash 6 and the quotient is 2. Now this is again pushed onto the stack. So what is pointed to by top? 2, right? Now what will happen? Which is the next operator? Plus. Plus is an operator, so popping. Okay. Now when you're popping the operator, operands from the stack, how many values? Binary. So 2 values to be popped and then you would have 25 and 2. When they are summed up, it yields 27, which is an operand. So it would be pushed onto the stack. Now 27 is pointed by top. Okay. Now as you move across, you see the last element in your expression, which is the operator. So minus, on encountering minus, that is a binary operator, you pop 2 elements out and this would be 27 and 30. Okay. So how is the division? Not the first element, but the not the first popped element, but the second popped element minus the first popped element. Okay, so this is the order in which it has to be done. Now this order has to be kept in mind in while doing the symbol exponentiation, division, subtraction, modulus, etc. Okay. So 30 minus 27 and the answer is 3. Now 3 is an operand. So now this would be pushed to the stack. What happens? This value would be pushed to the stack and this is how your stack would look like. Now I find that I have reached the end of the postfix notation. Is there anything else to be evaluated? No, right? So since this is the end of your postfix notation, pop everything from the stack and then leave all the parentheses and only the value. So the final result is 3. So 3 is the final answer for your entire postfix notation. Okay. So I hope this is more clear to you because this tabular form would better understand. First you need to understand the algorithm and then when you look into the table this would be a little more clear because upon encountering an operand what is to be done, on encountering an operator what is to be done. Okay, and the other thing that you need to notice the values in the case of exponentiation, division and subtraction, how is the order of the values. Okay, so once you consider this also during evaluation of a postfix notation. Okay, now this is the same example that we saw in the last class also, but here I included this because this was the case of a logical expression, right? Now you here true or false are considered to be your operand values. The other not and or are the operators. So the same thing follows here also. When you're encountering true or false, you need to push to the stack. When you're encountering the operator, decision, unary or binary is taken and then the values are popped and evaluated. So when you encounter true, false and true, what is the action to be taken? Pushing, right? So the pushing happens in the order or in the sequence in which the values come. First true would be pushed, later false and then true and now top is pointing here. Okay. So what is the next thing? Next is your operator which is not. So when you encounter not, you need to pop. Since not is a unary operator, how many operands are popped? Just one, pointed by top, true. So what would be not of true? You get false. Now false is again an operand, and so hence it is pushed to the stack and the top is pointed to false. Now after that you encounter an operand, it is pushed to the stack and your top points to the second false in your stack. After that you encounter OR. When you are encountering OR, what is to be done? Popping. OR is a binary operator. How many values would be popped? Two values. And hence after the evaluation of the expression you get the result to be false. This is again an operand which is pushed to the stack. Okay. So this is where your top would be pointing to. So as you proceed, you will see next operator and again pop two values. You would be popping false and false. Compute the expression. What is the result? False. False is an operand. Push it to the stack. Now here is where your top would be pointing to. Now as you move towards the expression, you have the last element in your postfix notation, which is the OR operator. Upon encountering OR, pop how many values? Two values. So both the values would be popped and then the result is true. Now this result would be pushed onto the stack. And then when you go back and look at the postfix notation, you see that your postfix notation is over or you have taken even the last data element. So what is the result? The result is true. Okay. Hence the result of the entire postfix notation. Now which was the postfix notation that we learned right now? It was the logical expression. So today, though we have covered the stack applications in the last class, we just went through certain problems, working out of problems wherein the question and the answer were given in the same slide. But in some cases, we evaluated the expression. In some cases, we drew it in a tabular format, wherein the status of the stack was also shown as in a column in the answer. Okay. So in either ways, the question can be asked for your forthcoming examinations. You would be either asked to convert it into a postfix notation or the postfix notation to be evaluated. Okay. Now the postfix expression, whenever you evaluate, you get a value. It is not just the alphabets or it is not just any other symbols, but usually the values would be given for the operand and you will be asked to compute the final result. Okay. So with this we have come to the end of today's session, and today we were looking into the sorry So today we just saw some sample problems or computation using the stack applications. So with this note, and we have come to the end of today's session. And let me bid good night to all of you. Now before bidding good night, reminding you once more of my promo code SLYT, which would fetch you in getting a 10% discount in the Unacademy subscription fee. Okay. So wishing all of you a wonderful Diwali. Thank you all. Hoping to meet all of you in the more of you in the next session. Thank you.